Okay, right. So now let's consider this problem, right? So now just read the problem, right? A plate having an area of 0.6 meters squared is sliding down the inclined plane at 30 degrees to the horizontal with a velocity of 0.36 ms minus 1, right? And there is a cushion of fluid. See, this is the cushion of fluid, right? I hope you can see the thickness, right? So that means in between this plate and the plane, right? The space in between the plate and the plane, right, is filled with a fluid, right? So what is the thickness of the fluid that is filled, right? So the thickness of the fluid that is filled is 1.8 millimeters, right? See, this is that, can you see? This is that gap, right? 1.8 millimeters, right? So there is a cushion of fluid 1.8 millimeters thickness between the plane and the plate. Mass of the plate is 28 kilograms, right? Find the viscosity of the fluid and be very careful. That means like always just look at the values that are given, right? So every time do not consider G equals 9.81 because in this problem it is given that take G as 10 meters per second square, right? So now we have to find the viscosity, right? So this is the equation that we are going to use. Shear stress equals dynamic viscosity times strain rate, that is du by dy, okay? And here we have to find the shear stress. What is this one? What is this guy? This guy is the shear stress, right? What is shear stress? Now shear stress is force divided by area, but be very careful, right? So now here this force is the force that is parallel to the considered area, right? Here this force is actually parallel to the effective area, right? Because generally we consider pressure, right? So you know, generally pressure stress we consider as that force divided by area. In that case actually the direction of the force is actually perpendicular to the area, right? But here be very careful, it is not like that. Here we have to consider the shear stress, right? So that means force divided by area, but this force, the direction of this force is actually parallel to the effective area, right? So now this is the, now here what is this W? This W is the weight of the plate, right? So what is the weight of the plate? 28 kilogram mass. So the weight of the plate is 280 newtons, right? So now we have to consider the shear stress. That means this is 30 degrees, this is 90, this is 60. So what is the component along the direction of the plate? That will be 280 cos 60, right? 280 cos 60 means half. 280 multiplied by half is 140 newtons, right? So we know the force. So the force will be 140 newtons divided by what is the area? 0.6 meters square. 0.6. Plate having an area, the effective area. So stress is known, mu we have to find. But here actually if you are going to consider this du, actually you know that what is that du? That du is actually the change in velocity. Yeah, focus. Du is actually the change in velocity, okay? That is something that I want to tell, right? So now change means here they have not mentioned about an initial velocity, right? They have not mentioned anything about the initial velocity, but they have mentioned the present velocity. What is that? What is the present velocity? 0.36 meters per second. So let's consider change as like du component as 0.36 minus 0, right? Okay, because it is not mentioned about starting velocity, right? So let's take the change as the present velocity minus 0, right? So du known. What is dy? Dy is actually that thickness. 1.8 millimeters. Be very careful about the unit. So 140 divided by 0.6 equals mu dynamic viscosity times du we know that is 0.36 divided by 1.8 millimeters means 1.8 into 10 to the power minus 3, right? So that's it, right? So then what is mu? Mu will be 140 divided by 0.6, right, multiplied by 1.8 into 10 to the power minus 3 divided by 0.36, right? So the answer you will get, now here this mu stands for dynamic viscosity, so the answer you will get in Newton seconds per meter square, right? The answer is something 1.166, right? 1.166, right? So if the answer is given in poise, right, you know that 1 Newton seconds per meter square equals 10 poise, right? So just multiply that by 10. So then you will be getting the answer in poise in 11.66. 11.6 is poise, right? Yeah, so that's it.